You are the pioneers. With your visions, your ideas, and your passion to make things better. And we are the ones who protect you from pitfalls. We are by your side whenever needed as a true fellow. Reliable, pragmatic, realistic. Together we make your product come alive. Imagine you enjoy improvement. Process Fellows.
Hello and welcome to my webinar, SPICE for Mechanical Engineering, what your customer really expect. My name is Timo Karasch from Process Fellows. We support you to enjoy improvement. We are your partner in assessments, consulting, coaching, and training to support you to manage complexity in system development. If you got any questions for our services, I will give you my contact data at the end of this short webinar. A little bit about me. I'm a certified principal assessor and instructor for Automotive SPICE. But besides Automotive SPICE, I as well am expert in Mechanical SPICE. As a member of the working group of Intex for Mechanical Engineering, I'm one of the developers of the new model of Mechanical SPICE. Let's start with the webinar, SPICE for Mechanical Engineering 2.0. Maybe you're already familiar with Automotive SPICE, and maybe you're even familiar with the old model for SPICE for Mechanical Engineering. In this overview, I'm going to give you, first of all, a mapping of the Mechanical SPICE model to Automotive SPICE. As you know, the mechanical part, it's a plug-in for Automotive SPICE. So let's see how they map together, how to combine them, and what is the idea behind. Then we try to dig into the model of Mechanical SPICE. We will have a look at the processes, and I will give you a little bit of background about the expectations in all the processes of the new model. Then we will talk about the customer requirements and the expectations. So is it really something that we need to do? Is it important for us to work with Mechanical SPICE? And at the end, I will try to give you some hints for implementation here. Let's start with the model and the mapping to Automotive SPICE. Hopefully you already know Automotive SPICE and the same Mechanical SPICE. They are just a model. They are just defining what is expected, but they are not defining how it should be implemented. They do not define a life cycle, and they do not have a mandatory principle of the hierarchies that you got in your product. Your product structure might look different. Here's a very easy example of a product. And you see already there are a lot of different colors because you have a lot of different sub-elements, subsystems in your overall system that you're going to develop. So if you look with the eyes of SPICE to this kind of product, you can map all the different processes or process areas to your product. In red, you can see this is the idea of system development. So everywhere where different domains come together, for example, here on the very high level, you see there are mechanical parts, but as well electronic parts. There are even software parts inside. So it's a mixture. And every time where you've got a mixture, it's system development. You've got the dark blue. This is the software development, and you've got the green one. This is the mechanical development, so the electronic development. On the right side, we will see the light blue elements, and this is where we've got the mechanical development. But mechanical development can be defined in different complexity. You see, on top, there is a mechanical system, means it's a combination of multiple elements of the mechanics. And on the lower levels, you have the mechanical component, so only a single component that is developed here. Those disciplines are now defined within the models. On the left side, this is part of Automotive SPICE 4.0 that has been published. You see, it includes already system development, software development, and in the new version 4.0, it includes as well hardware development and the machine learning part. The idea of mechanical SPICE is now to define this plug-in. So it defines the development of mechanical systems and mechanical components. In the old model, it was divided into two elements or two groups of processes. Now you will see it's a kind of combination. So combined description of mechanical system and component development. In the new version of Mechanical SPICE, it is consistent to the idea of Automotive SPICE 4.0. So it uses the same vocabulary, it uses the same structure, as you will see. On the left top, you can see the picture of Automotive SPICE 4.0. You can even see that there are parts for system development over here. You see that there are the processes for software development and for hardware engineering, so for the electronic part. The mechanical SPICE is an idea of a plug-in principle, so this is what you see down here, and you see mechanical SPICE consists of 5 processes. Those 5 processes I already mentioned are consistent with the idea of Automotive SPICE 4.0. And this is why the description of the processes can be compared to what you already know from Automotive SPICE. The first process can be compared to SYS2. So it's about requirements analysis, following the same structure that you, for example, see in the SYS2 process. Then we have an architecture process. An architecture process can be compared to the SYS3, to the system architecture process of Automotive SPICE. On the bottom, there is something special, and this is the interface to production. So it's not the production itself, as you will see later, it's just defining the interface between your development and the production side that you need for mechanical development. And on the right side, you see the verification processes that then can be compared again to the system process of Automotive SPICE for integration and integration verification and for the system verification process. On this page, I try to compare it with the idea of the system development processes. But if you're already familiar with the Automotive SPICE model, maybe it's helpful for you to even have a comparison to the software development processes, because this is happening on the same level, as I already explained, software development in parallel to mechanical development or hardware development. Here you can see both parts. On the left side, the mechanical engineering processes, 5 processes. On the right side, you see the software engineering processes that you know from Automotive SPICE. Let's try to see why we have 5 processes in mechanical engineering, but the 6 processes in software, and you will see it's not that different. So the process of mechanical engineering 1 and 5, you will see here the requirements and the verification against those requirements. This really can be compared to what you see as well in software. The requirements for the component that needs to be developed and the verification against those requirements. So this is following the same idea. One level below, we again have the same idea. The mechanical engineering processes 2 and 4, so the architecture and the integration and verification against the architecture is the same than what we see on the high level of the software, where we have a software architecture and then integration and verification against this architecture. Now it's getting a little bit tricky, and this is when we look in the lowest level here. SPICE for mechanical engineering, it splits the idea of software 3. So if you look into software 3, you see it's the software detail design. So it's more a design, so part of the architecture. And it's the unit construction, so the realization really. And this is where you see the development activities itself. It is still in the MEE2 process. So the idea of a design is part of the architecture here in MEE2. The physical production itself, this is what happens afterwards. And remember, this is the part of MEE3, but not the production itself. It's more the interface to the physical production here. And then we can jump to the right side to see the verification. So the results of this production process, the MEE3, this is the physical mechanical component that comes back from your sample production. This is then part of the MEE4 process. So this is checked in the verification of the integration part. And this is what here in Automotive SPICE you would see in the software 4 process itself. Just again, to make it clear, the MEE3 process, it's a sample production process, but it does not describe the series production itself. It just supports the sample manufacturing, as you will see when we come to the details of the processes. Here is a picture of the structure of the processes in mechanical engineering. In green, you see the left side of the V, talking about requirements in architecture. On the right side, you see the verification activities, the integration and verification. And in yellow, you see again the interface to the production. What you again can see is that this principle of processes is described only once. You have MEE1, just dealing with requirements in general for mechanical engineering, and MEE2, dealing with architecture and design for mechanical engineering. But it can be used in a multiple way. And this is what the pictures in the middle of this picture should show you. So you start with a mechanical system. So it's a pure mechanical system. This is why it's not Automotive SPICE system development. Here, you do not have any kind of electronics or software inside. It's only pure mechanical engineering. Typically, you have an idea, and this is just the model that you see over here defining this kind of mechanical system. If you split the system into subsystems, you will see it's still a combination very often of parts. So one mechanical system may consist of several subsystems of mechanical parts. And at the end, you go down to the very lowest level, and this is really the idea of a mechanical component, so one single component. So in this example here, you see we use the processes for multiple parts. We use the requirements and architecture processes for the overall mechanical system on the top level, for the subsystem, and for the mechanical component. Each level will have requirements and a description of architecture or design. The idea of the component sample production then is this transfer. So this idea of a component is transferred to a real physical product. And now we will start on the right side, and typically we have the same steps then on the right side. So a mechanical component will be verified against the definition of the left side, and every mechanical system will be integrated and verified against the definition of the left side. And this is why you see multiple levels, although there are only here the processes defined once in the model at the end. Let's go inside of the processes, and then maybe it's getting a little bit clearer. We start with the first process, and this is MEE1. It's called Mechanical Requirements Analysis. In this picture, on the left side, you can see the purpose, and it is defined in the model. So let's have a look at the purpose. The purpose is to transform the mechanic-related parts of the defined upper mechanical system requirements and upper mechanical system architecture into mechanical requirements that will guide the design of the mechanical system and mechanical components. You already can see that it is a kind of combination because we talk about mechanical system and mechanical components, and this is what you see on the right side. Remember the picture of the previous slide? We can have mechanical systems even at different levels, and we go down to a single mechanical component at the end. So, with the focus of mechanical system and components, what does it tell us? We need to transform mechanical related parts, and this is coming from upper system requirements and upper system architecture. So every time when we talk about mechanics, remember the picture at the beginning of the presentation, it is typically part of an overall system. It might include electronic parts, software parts. So you have a complex system and you break it down. Everything that is defined on upper level, yeah, on system level, on requirements and architecture that belong to Automotive SPICE System 2 and System 3 processes. This is used as an input. And in this description of the overall system, we try to identify the mechanic related parts. So what are the requirements coming from the upper system to the mechanics? Requirements that need to be implemented, fulfilled in the mechanical part of our development. So we use the input of system and requirements and architecture of the above system, and we derive now requirements, and requirements guide the design, so help us to design at the end the mechanical system on different levels maybe even, and the mechanical components. What is special if you compare it to the old model of mechanical engineering that you might see, then you will see that the base practices, first of all, they look pretty much the same to what you already know. They even have the same structure as you can see in the System 2 system requirements analysis process. Everybody is not familiar, you're free to contact me, but system requirements analysis in Automotive SPICE, it's mainly focusing on the specification of requirements. So write down what you expect here, what is the behavior, what is the functionality of a system, like a mechanical system or a mechanical component, and talking about the analysis. So is everything that we defined complete, consistent, realizable? This is the main idea of the system development processes. And what you can see here in the mechanical process is that we got examples for structuring criteria. Because in mechanical engineering, you will group the requirements as well, but maybe in a different way than you do it on system level or on software level, for example. And one example is given here, the functionality or the expressing product variants. Grouping by product variants, because mechanical engineering very often here will have a couple of variants that need to be realized here. And the prioritization is defined. There is a note in mechanical requirements analysis process about the prioritization, and this can be done according to project or stakeholder needs. And one example is given the definition of a release scope like A, B, or C samples. So maybe there are elements or criteria that need to be implemented just in a different kind of samples. But very often even you will see that here some requirements can be verified, or the implementation of the requirement can be verified only in a certain sample. If you, for example, get X-ray requirements, you will not verify them already in an A sample. So those requirements might be mapped to a later sample to already address, hey, this is something that is going to given to verification at the later phase of the project then. And this is one of the ideas of the maybe already familiar idea of verification criteria. As you might already have seen in Automotive SPICE, there is not a specific requirement or base practice anymore for the verification criteria. So criteria that helps you to make sure your requirements are verifiable, but it is still a recommendation to have verification criteria. And that's an interesting part for mechanical engineering, because for mechanical engineering, you will not have 100% physical verification and of each and every requirement here. You cannot have physical tests for everything. It would be too expensive. And verification criteria might help you to already identify at what moment of time it should be verified, like A, B, or C sample, and what kind of method should be used for verification. So is it maybe a simulation, or is it a kind of calculation like FEM calculations, or is it really a kind of physical verification? That's the idea of requirements on system and on component level. Let's go to the next process, and this is the mechanical architecture and design process, MEE2. So the purpose is to establish a mechanical system architecture and mechanical component design. And you see again here we talk about an architecture, and a CAD model, for example, of a mechanical system is an example of such a system architecture, and a component design. And this is where maybe you have a kind of drawing for a single mechanical component here. So Mechanical system architecture and mechanical component design comprising static and dynamic aspects, consistent with mechanical system requirements and mechanical component requirements, and to evaluate the mechanical system architecture and component design against defined criteria. So we have this kind of system or component description. It needs to be consistent with the input, so with the requirement that we just saw in the MEE1 process. We will define it in a static way, like a kind of picture, but as well in a dynamic view here, like the moving of parts that we try to see, or vibrations of part, or the difference in temperature that we will see. But it's not only the description of this kind of system or component, it is even the evaluation. So we need defined criteria and we need to evaluate to see whether this is really a good solution. Does this fit our idea here? Does it fulfill the requirements or the criteria that we define for it? We will see that there are base practices now for the description of the static and dynamic aspects. So one base practice focusing on the static description, another one more on the dynamic aspects. That's the new structure that we can see in Automotive SPICE as well. What are examples of technical aspects that need to be checked or evaluated? And you see this is where manufacturability comes in place for mechanical engineering. Suitability, pre-existing elements, for example. Can we reuse some elements here? Or can we use standard parts here? What about availability of elements? This might be part of evaluation of our architecture as well. And if we start those kind of analysis, we go back to methods that are already very familiar for mechanical engineering, like prototyping, simulations, qualitative analysis, or simulations, FEM, FMEA, quality function deployment. So a couple of examples or already well-established methods might be used for evaluation. The idea of this analysis or evaluation of architecture is that maybe you see an improvement here. For example, you perform an FMEA, you see a potential failure, and out of this potential failure, you think about an update, an improvement of your architecture based on the identification of possible failures. And another result could be a verification that you see, hey, this is a potential failure that we need to cover in verification, so in a testing process in a later phase. Those kind of analysis methods are used. And one part that is new in the definition, even in Automotive SPICE, is important for mechanical engineering as well. And this is the identification of special characteristics, typically coming out of FMEA, here, simulation, risk analysis, sizing calculations are mentioned here. So one result of your analysis need to be the identification of special characteristics. That is part of mechanical engineering as well. Doesn't matter on what level you do it, as long as you can show that you identified them. And there is another base practice that is special for mechanical engineering, and this is consider, determine, and document the design constraints, because for mechanical engineering, you might have specific constraints like sizing or weight or something like this. And this is something that should be considered in detail. And this is why there is one specific base practice that you will not find in the Automotive SPICE world, because this is special for mechanical engineering. Let's go down to the top, and this is where we look at MEE3, the mechanical component sample production. Look on the right side, you see again here, this is the input. We have a definition of the component itself, and we have, for example, a drawing with sizing, etc., with all the values for the component. And we talk about realization, so we might have a couple of samples here out of this process. So what's the purpose? Purpose is to produce a mechanical component sample that reflects properly the mechanical component design and mechanical component sample production specification. So production of a sample, but please again remember, it's not the production really that is in focus here, because this is another part of the company typically. It's more looking from the development part, because the interface between development and production is a very important one. So we need to make sure that all the samples that are coming back from sample production really reflect the ideas of the component design. And this is what we here defined in the process before. And talking about sample production specification. So what are maybe specific requirements to be covered during production? And this is why, yeah, you will see there is one important base practice. It's about develop mechanical component. So showing that it's not focusing the production itself, it's more the development here. Make sure that all the data for the mechanical component is complete and is transferred to the production site. Agree on mechanical component sample production specification. This is the kind of communication that the development side need to communicate with the production side to agree really on product specification. Like what criteria need to be covered, what kind of methods might be used, or what is the amount of samples that we need at a certain moment in time, what kind of checks of verifications are necessary for this kind of samples. Then to produce the mechanical component samples, to ensure and support it, make sure that you really receive the samples that you expect in development part. And the real challenge for mechanical component sample production process typically is that it depends really on the moment of time where you look inside of such a process, what really what kind of tools, for example, are used. So because it is not that you have a clear separation of, hey, this is only focusing on the development part, and this is now going back to serious production. And this is what this arrow at the bottom should show you. So production changes over time, starting with the first sample that is giving you a first idea of whether your development goes in the correct direction or not. Talking about sample production, to have samples that you can use for prototyping later on. And then there is one moment in time where you start to use serious tools even. Here you have a pre-series, you have serious production later on. And this is where the production is more in focus. And this is where other standards like IATF will come in place. There is no contradiction of mechanical SPICE, talking about the MEE3 process, and the IATF standard for production. It is more a kind of connection that, in earlier phases, you will have the focus more on the development part, checking the processes with MEE3, and later you're more on the realization part, you're more into the idea of IATF standard. Now let's have a look at the right side. ME4 is mechanical integration and verification against mechanical architecture and design. You see already the purpose is divided into 3 parts. First, we need to verify the components against the mechanical component design. So we have now here single components like here, and we need to make sure that those components that are coming back really fulfill all the definitions of the component design, like they fit to the drawing that we defined. Second, to ensure the integration of the mechanical elements into an integrated mechanical system consistent with mechanical system architecture. Here, and on the right side, it looks a little bit like you're playing with Lego. You have a couple of components and you have some steps. Here, please combine those components. And the idea of what comes out at the end, like such sub-assembly groups or the complete assembly group, this is coming from your system architecture. And the steps, how to build it together, how to assemble those elements. This is called integration of elements. And last but not least, to verify the integrated mechanical system against mechanical system architecture, because every time where you put elements together, you might have specific requirements for a specific fit, or it still should be able to move, to turn, or something like this. So you have checks. Every time where you put something together, you might have as well a kind of check, so verification of this assembly step. The base practice in Automotive SPICE and as well in MEE4 is talking about verification measures. This is a new definition, so we do not talk really about test cases anymore. We give a more generic approach of verification measures because it might not be a physical test really, or everything here that you really understand as a kind of test. It might as well be a kind of review here, just checking whether it fits together here, just looking whether it fits as you expect. Or it might even be a kind of simulation here. You can use prototyping for this kind, or it might be something that is calculated. And at the end, it is important that all the inputs, all the requirements, all the definitions of the architecture are verified in a way, in an appropriate way. And this is why, yeah, we give it a more generic name, calling it verification measure. So every requirement or definition of the architecture will lead to a kind of verification measure, a measure how to verify the implementation. Then we have the mechanical component design verification. Yeah, so verification against the component design. So every single component fits really the definitions of the design. Then we have the definition of the integration sequence instruction. And sequence instruction, this is something like an assembly plan where you really know how to build sub-assemblies or complete assemblies. Here, what are the necessary steps here? This is called integration sequence instruction in Mechanical SPICE. Then we need to integrate the mechanical system elements and perform the integration verification. So putting it together according to your instruction and checking those assemblies here. And with this result, we come to the last process. Then this is the MEE5 process. This is the verification against mechanical requirements. And on the right side, you can see again, here, it already starts only with the component itself, seeing whether the component fulfills requirements for the specific component, but as well focusing on the system again, so that the complete system realizes the requirements. So the purpose is to ensure that mechanical components and the integrated mechanical system is verified to provide evidence for compliance with mechanical system requirements and mechanical component requirements. So verification to show an evidence or to give an evidence that you are compliant to component requirements or to system requirements here. That's the idea. Here. So again, you will see that we have the verification measures, and those verification measures like physical testing, simulation, prototyping, reviews, etc., they used to verify then components and the system against the input. Verification measures, they will cover as well something like thermal, environmental, robustness, lifetime tests. So these might be aspects that you know as a kind of validation, even performed in a kind of product validation. So focusing on the complete product at the end. But please make sure this might even be affected here in MEE5. So although it is called verification, you can see it might even cover other here test principles that are necessary or that are typically performed for those kind of mechanical products. And here at the end, one recommendation would be to have a kind of strategy. Yeah, so an idea of what are the purposes or the scope of the different test levels to see at what level do we cover thermal, environmental tests, etc. So much about the 5 processes. Now let's have a look at the custom requirements and expectations. And this box is showing you one part that is documented in the model itself. So the model SPICE for Mechanical Engineering itself defines already when should you use Mechanical SPICE and when is it maybe not a good idea to use it. So it shall be applied for organization or supplier which develop or change the system or component on basis of the customer requirements. So every time where you've got customer requirements, this means you will have a specific development according to those requirements. Doesn't matter if it comes from any kind of external customer and you're a supplier, or maybe even another part of your organization that delivers those requirements. Every time where you have development according to requirements, yeah, you shall do it according to SPICE for mechanical engineering. Or organization or supplier which develops a system or component based on off-the-shelf items. So even if it's based on off-the-shelf items, but it's still a development, so a kind of change here, you update something based on this idea, then you still have the idea of development. And this is maybe the idea that you should keep in mind every time when we talk about development. We are not alone in mechanical engineering. Yeah, we have interfaces to other elements of the system. We have interfaces to electronic development, for example. Here, we need to manage the complexity. We need to work together with customers, with suppliers, and this is where the idea of mechanical engineering can help you to have a clear understanding of the development activities, of the development processes, and of the interfaces between all parts here. So use mechanical engineering whenever it is about development. Optional applied for organization or supplier which delivers a system or a component which is provided off the shelf to the customer. So if it's really something without clear development, not focusing on any kind of requirement, yeah, it's like you buy a part. Hey, it's optional, you know. It might be really too much to really think about mechanical engineering, but again, please think about it. It might be an internal aspect as well. Mechanical engineering nowadays is not the same than a couple of years ago. It is more complex. Here, it's a lot of people working together, and so it should help you to manage all the activities within engineering. But it's optional if it's just a delivery of an existing component here. So no need to redo everything. This is the customer view typically. So the customer knows, hey, there is a kind of development part. This is where we will look with the eyes of Automotive SPICE typically, and we have a series. Okay, this is where at the end we can have a proof with your verification that you performed. And somewhere in pre-series, we have a kind of component release where we know, hey, the customer expect you deliver a component, you deliver all data for this component, and we have a component release. Yeah, we prove that we can use this component in this way. And the customer knows that for everything that comes afterwards, ITF is sufficient. ITF will focus on everything that is something about production, but just given a very generic idea of the development part. And this is why the development part should be covered. And this is what is typically a kind of expectation of customer, or this is even what a kind of agreement looks like that some of the customers already give to their suppliers. And this is what you see over here in this box. The supplier shall develop the mechanical components on the basis of defined processes, for example, according to SPICE for mechanical engineering. So in most cases, you will not see really mandatory requirements for SPICE for mechanical engineering, but it is given a kind of recommendation here. You need defined processes, and one idea is to do it according to SPICE for mechanical engineering. So it's nothing mandatory for all the development for mechanical engineering, but it's here recommended. And this is something that you should keep in mind as well here. It is a kind of recommendation. So it is not really used for the kind of check of the capability of your development processes. It's more support to help you to identify improvements for your development activities in mechanical engineering. But as this is already part of the agreements, it might even be something for the future that comes really or becomes a mandatory part. This is still up to the customers. Finally, let's have a look at some hints for usage of mechanical engineering. In my history, I already performed a couple of trainings for mechanical engineering. I even supported a couple of companies in the implementation of mechanical SPICE, and most of the time it was more to manage complexity between all the development activities for mechanical engineering, and especially the change of generations because what I said already, mechanical engineering changed over the time. But I as well performed some assessments, checking the capability of mechanical development in some companies and to see, hey, where is room for improvement? And out of my experience, I try to give you now some hints. Identification of synergies between different areas. And this is important for every company. You are familiar with mechanical engineering for many, many years. And even all the people in mechanical engineering, they have a lot of experience. But this experience is somewhere in their mind. And very often you can see that there are maybe same approaches, but even different approaches in different areas of your company. Try to find synergies. So you need a kind of language that everybody talks, and mechanical spice is about processes, and processes is like a unique language for development. So use this unique language to identify those synergies here. Knowledge retention in mechanical development. You have experienced people, they know what's going on. And I can tell you that I had a meeting with a company, and I talked to one person of testing, and it was a very, very experienced guy. He was pretty old, to be honest, and we talked about his testing activities, and he said, hey, I got everything in my mind. I know how to build up all the tests, how to execute the test, or how to check the result of the test. And we finally asked him, okay, is it documented somewhere? And he said, no, it's just in my mind. And we asked him, so I'm pretty sure you want to retire here somewhere at some moment in time. What about your knowledge? And he then needs to say, no, okay, this is lost. Here. When I'm gone, it will be lost. So make sure that the knowledge is not here getting lost. Make sure it is documented somewhere, and processes is the best way to keep knowledge. And it's not that then everybody can do this kind of job. You still need your experienced or well-trained developers, but yeah, you can give the ideas or the expectation or the knowledge to all the others within the company. Restructuring or structuring activities and work results for phasing in new employees. You have new people joining the company, and they need to have an understanding. They are coming from university, maybe they are trained, they know what's going on in mechanical engineering, but they need to see how it works in your company. And this is giving them a structured approach. Those are the activities that we expect from you. Those are the work results that you need to deliver. And it's easy for them to understand it. It's not training on the job, it's as well training based on existing processes here. Identification and avoidance of systematic errors early in the project. It was easier in the old times, where you got to focus only on mechanical engineering, but I already mentioned this time is over. There is a strong relationship to electronic development, and you're not able to identify systematic errors that easy anymore. And this is helping you to check your results, check the dependencies early to identify those errors. Interfaces to hardware as part of system development. Here, every time where you look in a mechanical component, just imagine what this component might look in a couple of years. So the pure mechanical parts, I don't think they will stay really that long. There will be an interface to hardware to electronic part, and this is something that need to be defined. So it need to be developed together, and processes are focusing on interfaces. And combination with ITF 6949. So the ITF standard, I think I already mentioned here, the main focus of ITF, I know it is the production part. There are requirements for development as well, but on a very generic way. And in many companies, there are already auditors talking about ITF, and they know we have only very generic requirements for development. So do you have any other standard that is focusing on the development part, that is looking deeper into the development part? And this is why very often ITF auditors are already asking for SPICE. Do you have processes maybe according to SPICE? Do you perform assessments according to SPICE? Do you identify any kind of process improvements and implement improvements based on SPICE? So there is a strong relationship, and this is something you can see even in the mechanical SPICE here. It is not a redundancy, it's more a combination of both standards. Here and finally, systems, process improvement, and capability determination. This is the idea of SPICE. So SPICE is just the abbreviation of systems, process improvement, capability determination. And please remember here, mechanical SPICE, it might be used for capability determination as well, that you can see how capable your processes are. But please identify it is mainly about process improvement. And this is something here that should be important for you as well, to identify process improvements, because the cost pressure, I think it is here known to everybody, and to reduce costs in development can be already an idea of clear structured processes here. And that's it. I'm done with my presentation, with my webinar for SPICE for mechanical engineering. If you got any question regarding SPICE or the mechanical SPICE, feel free to contact me or go on our webpage of Process Fellows. Here, I wish hopefully a lot of fun with SPICE for mechanical engineering. And I can tell you really, I worked with mechanical engineering for a long time now already, and I talked to a lot of mechanical engineers. And at the beginning, I know they're a little bit confused about, do we really need this kind of processes, and do we need a kind of standard that tells us of how to deal with mechanical engineering? But very often, the idea of mechanical SPICE was a kind of starting point to start a discussion, to discuss the aspects of their daily work. And then at the end, this was given them a very good idea of understanding their own processes that they are using. I say thank you to everybody and see you next time. Bye-bye.
You are the pioneers. With your visions, your ideas, and your passion to make things better. And we are the ones who protect you from pitfalls. We are by your side whenever needed as a true fellow. Reliable, pragmatic, realistic. Together we make your product come alive. Imagine you enjoy improvement. Process Fellows.